Okay, we're being asked to solve this equation. There are two different ways of doing this. The first way is the way you'd actually see in an intermediate algebra class. We'll call that method 1. I see a radical, and in intermediate algebra they will tell you to solve a radical equation. What you do is you get the radical on one side by itself, start squaring, and hope you can just keep that procedure going until you actually can solve the equation. So the first thing I'm going to do is I'm going to throw the radical over on the other side. So I'm going to get 2x minus 2 equals 3 square root of x. I put parentheses over here because I knew I was going to square. I'll get something like that. Now remember, to square something means to multiply by itself. It doesn't mean to square each term. So I have to multiply 2x minus 2 times 2x minus 2. We FOIL there, and we're going to get 4x squared minus 8x plus 4 equals 9x, like that. That's just a normal quadratic equation. To do this, we always get 0 on one side, and we hope to factor first. I'm going to throw the 9x over, so I'm going to get 4x squared minus 17x plus 4 equals 0. I'm going to try to factor that, like this, equals 0, like that. I can go 4x, 4x, or 2x, 2x. I'm going to go 4x, x, like this. I see a minus and a plus, so I know this is minus, minus. I see that if I put a 4 here and a 1 here, I think it works. Now if I set this piece equal to 0, and this piece equal to 0, and remember, the reason you're doing that is you're multiplying two things together to get 0. One of them's got to be 0, right? The first one tells us that x can be a quarter. Move it so we can see this a little bit. Or x equals 4. Now, the problem is, when you square both sides of an equation, you almost always add extra solutions that were not solutions to the original. That's part of the problem with doing it this way, although checking is going to be a regular feature here. Let's plug in 4. If I plug in 4 here, I get 8. If I plug in 4 here, I get 6. So I'm going to get 8 minus 6, that's 2. 2 minus 2, that's 0. Yay! This one works. Let's plug in a quarter. 2 times a quarter is a half. See, the square root of a quarter is a half, so I got a half minus 3 halves. That's minus 1. Minus 1 minus 2 is minus 3. That ain't 0, right? So this one is eliminated because we checked our answer, and we can see we only get one answer. So that's how you would solve it in an intermediate algebra class as a radical equation. It works. Sometimes the numbers can get huge, because when you square even medium-sized numbers, you can get monstrous numbers. Now, I want to do this like you would do in a college algebra class. In a college algebra class, what you're going to do is you're going to say a quadratic type. So I'm going to write down as an equation. Now I'm going to say quadratic. I'm just going to write quad because that's actually usually what they write. Of quadratic type. Ta-da, there we go. Now what does that mean? That means I'm going to look at this like a quadratic equation. I would like to factor. Now when you first see these in a college algebra class, they'll tell you to substitute. After a while, they don't want you substituting anymore, but we're just recapping, so we're going to substitute just the beginning. What I'm going to do is I'm going to write down that w equals square root of x. Now why did I do that? If w is square root x, then this right here is going to be 2w squared, and it's going to start looking more and more like a quadratic equation. Now, I want w to be square root of x. I have to square both sides to get x. And by the way, that's bad news. Whenever you square something, square both sides of an equation, you can add solutions. We're going to have to check that later. No fun. Anyways, I'm going to plug in. Instead of x, I put w squared, like that. Instead of square root of x, I put w, like that. And then I put minus 2, like that. And that's just an ordinary quadratic equation. It should either factor, I complete the square if I'm, masochistic, or I can use the quadratic formula. I'm going to try factoring first and hope it works. I see 2w squared there. The only way that's going to factor is if one of them is 2w and one of them is w. I see a minus and a minus. So one of these has to be a minus and one of these has to be a plus. I see a minus here. I'm thinking because this one's bigger, I'm going to put a minus here and a plus here and hope it works. If I put a 2 here and a 1 here, how does that work? 2w squared minus 3w. Yeah, it works. Yay, right? Again, we're multiplying two things together to get 0. One of them has to be 0. So either w is equal to minus a half or w equals 2. So it looks like we have two answers. But remember, our original equation didn't have w's in it. It had x's. So I'm going to have to substitute back. So wherever I see a w in my box down here, I'm going to put square root x. So let's put this down. So square root x equals minus 1/2 or 2. Now, in the last time we did this, when we solved this as a radical equation, first off, you can see that one was messier. There weren't two answers, there's only one answer. And here it looks like there's two. But here's the deal. When anyone ever writes the square root of x, they only mean the positive square of x. If they wanted the negative one, they would have put a minus in front of it. So when I see the square root of x is positive equals a negative number, I know that negative number right off the bat is wrong. So that's wrong. Now we're almost there. I don't want the square root of x. I want x, right? So I'm now going to square both sides, and I'm going to get x equals 4, which hopefully is the same answer we got the first time. Yay. So that's actually how you would solve an equation of quadratic type. You look at that and you say, gee, that's almost quadratic. Can I substitute and make it work? Now, one thing I mentioned, by the end of college algebra, they're not going to want you to substitute. They're going to want you to just look at that and try to start factoring. Now, how are you supposed to do that? You'll do this in a trig class, by the way. It's actually harder to substitute there. So what I'm going to do, I'm going to try the same thing. If you look in the notes, there's a big, long handout from the college algebra class at Kent State, full of just wonderful problems and solutions, and this is how they do them. Now, if this is a quadratic something, right, this should be 3 times the something. This should be 2 something squared. So what they're going to do is they're going to put 2 square root of x right off the bat and square root of x like that right off the bat, and then try to start factoring. If I factor like this and like this, I mean, you can see we're factoring exactly the same way we did when we substituted. We just got to eliminate about 6 lines, right? Because our pattern recognition was better. Our pattern recognition was better. Now, if I set each equal to 0, like we did when we substituted, I'm going to get the square root of x here equals minus a half, or I'm going to get the square root of x equals 2. Just as we did last time, the positive square root of x can't ever be negative a half. So that one's automatically out. Here I square both sides. I get x equals 4. And what you're going to see by the end of college algebra, this solves very, very quickly. Very, very quickly. Much better than the radical equation method you'll see in intermediate algebra. Much better than actually substituting than you'll see at the beginning of college algebra. There are some nice videos on the website, and a lovely, lovely, long handout with lots of problems to do and solutions that you should look at if you feel rusty.